Howdy guys, Jimmy Song here. Welcome to another episode of White Paper Wednesday. This is the show where I go through and read basically some BIP or white paper or research paper or something like that. I've been doing them for a lot of this year so far, so I'm continuing that trend by looking up a BIP that I haven't really read yet. So hopefully it'll be something that you find useful. This is going to be about version extended WIF from my good friend Carl Johan Ohm. So let's get right down to it. Before I go on, please pound that like button and subscribe so more people can know about this stuff. I know it can be a little bit dry for some people, like learning about like the technical details, but that's kind of the point, right? I want you guys to level up. We're not Ethereum. We don't just trust like a small group of developers to do everything. We're a community that seeks to understand and verify instead of trusting. So anyway, with that in mind, this is BIP178 version extended WIF. This is from Carl Johan Ohm of Digital Garage. And basically, the whole idea is an extension to the wallet import format to specify what kind of Bitcoin address the private key corresponds to. Now, if you don't know what the wallet import format is, it's basically your private key encoded in base 58, and this is the basis of a lot of paper wallets and so on. And there are sort of ways to use the wallet import format with passphrases and stuff like that. I think that's BIP178. But this one is specifically about wallet import format, and the reason for it is in the motivation right here. There are several types of Bitcoin addresses which can all be associated with a given private key: pay to pub key hash, pay to script hash, pay to witness pub key hash, pay to witness pub key hash. So the first is the addresses that start with a 1. There's pay to script hash, pay to witness pub key hash. That's SegWit, but that's backwards compatible, so it's wrapped in pay to script hash, so it starts with a 3. And then there's pay to witness pub key hash. This is native SegWit, and these start with BC1. All of those can be locked to a single private key, right? Like it can be any private key. While private keys have a 1-byte suffix indicating whether the corresponding public key is compressed or not due to the suffix absence, there is no way of knowing what kind of Bitcoin address was associated with the private key. As a result, when importing a private key, the wallet has to assume all kinds and keep track of each possible alternative. So when you're a wallet and you import a WIF format key, you're only really told whether or not the compressed or the uncompressed public point was used. And since like BIP32 and SegWit and all that just use compressed keys, it doesn't actually give you much information. But there is, and as a result, the wallet has to keep track of a lot of all of these addresses and do that, and that's resource intensive and bad for bandwidth and all sorts of things like that. So by extending the suffix, we can specify what kind of Bitcoin address was associated with a given private key. So here's the specification. Currently, private keys are stored as a uint256 private key data, followed by an optional uint8 compressed flag. The latter is extended to specify the address type. So 01 is compressed or uncompressed. But now there's some other stuff. 10 is pay to pub key hash. This is the address that starts with a 1. 11 is pay to witness pub key hash. This is native SegWit BIP32. And 12 is pay to witness pub key hash, pay to script hash, pay to witness pub key hash, which is SegWit nested inside a BIP16 pay to script hash addresses starting with a 3. When a wallet imports a private key, it will have 2 outcomes. The key is using one of the legacy types, in which case all types must be accounted for. So if the key is using a legacy type key, then you have to like just look for one of these, or it's using an extended type, in which case the wallet only needs to track for that specific thing. So basically, these three are the extended types, 10, 11, and 12, or 16, 17, 18 in hexadecimal. And basically, like, it's a way to give a hint to the wallet saying, hey, this is a private key that corresponds to this type of address. Note the difference between 0, 1, and 1, 0 is that the former can correspond to any of the types above, whereas the latter only corresponds to the pay-to-pub key hash, legacy, non-SegWit. So there is a difference between 1, 0, and 0, 1. Compatibility. This proposal is not backwards compatible, and that software that does not recognize the new types will not understand the compressed flag. It would be trivial to change this by keeping the uncompressed state as it is, no suffix, and changing compressed to anything not 0 as opposed to the value 1. So most wallets, when they're importing WIF, they don't really actually use the compressed flag anyway. They'll check both uncompressed and compressed as a matter of course. So I don't think that's too big of a concern. The proposal is backwards compatible in that new wallet software will always understand the old WIF format, however. It will, as it does today, assume that any kind of Bitcoin address is possible and will have to track all of them as it has to today. Acknowledgements. This BIP is based on the initial proposal by Thomas Vogelin, thomasv@electrum.org on the Bitcoin Dev mailing list and the Electrum 3.0 implementation. There is a partial implementation which adds but does not use the types described in the BIP here. So let's take a look at the pull request real quick. I'm sure Carl did it. It's actually gotten close. Let's see what the objections were. Whoops, fixed. Ideally, we would first draft the spec of the WIF standard in the form of a BIP. And he did. This link is broken, right? I updated the link. Needs rebased. It feels wrong to store the address type in C key. C key is a representation of a private key, not an address. Address deviation and knowledge about that belongs in the wallet code, not the ECDSA wrapper. See, but the compressed byte is in the private key right now, and BIP178 extends it, so it feels like it makes sense to keep it in the key class. Where else would it go? The compressed flag affects the public key, not the address. Different private keys, including compressed flag, correspond to different public keys. Where should it go? Right now, nowhere. We can't use it as the isMine can't take it into account. Just looks at what we can sign. Import multi can use it automatically to figure out which redeem script, witness script to compute, but it will inevitably overshoot what it matches again because of the isMine logic. Later, it should go in the isMine recorded data, but it's not necessarily something associated with a single key, but with an entire record. I understand it seems easiest to store it in C key for now, but that's just due to the code historically conflating keys with addresses. I really try to avoid continue doing that. That makes sense. Maybe I should just close this PR then. I could always rework it to split out the WIF stuff from the key stuff. Would that make sense, or just a waste of time, you think? Well, so this is, yeah, I guess it got rejected. But yeah, I mean, the problem still exists, and I think Peter basically acknowledged that the problem exists. It's just that he doesn't feel that this is the place to put it. I am thinking about writing up a BIP for sort of like encrypting backup of wallet data, and maybe that's the place where it needs to go. So, but yeah, I mean, it's a good exercise to go through and think about all of the things that go into a BIP and what the core devs are thinking about. This does add overhead to wallets that are importing in wallet import format. So very, very good stuff. Anyway, hope that helps you. Fiat delenda est. This song is done.